we find the limit of this function here as x goes to 0. So there is trouble there when you plug in the 0 here. So it's going to be interesting to see what this limit is. So there are some by hand ways to do that, but we'll learn that later. Right now we're just learning what the limit is, so we'll use the calculator, put the function in, graph it. Notice that it ends right here, and there's nothing to the left of that point. Why is that? Because when x is beyond -1 to the left, the inside of this radical would be negative in that case, and the square root of a negative number would be, in the complex number system, definitely not a real number at that point. So that's why the calculator doesn't know what to do. There's no real valued y value here. Anyway, so what we do is we're going toward 0 is our goal. So we go down here from the left, and it looks like the curve comes down. Looks like it's limiting out to around 1/2. And if we come from the right, going this way, with our x's going down to 0 from the right, it looks like it limits out to the same place, somewhere around 0.5. So one way to be sure is to make it a table. So that starts with second table set, and tell it where you want to start and the increment, and you get a table such as this. And you see that as the values approach 0 from the left, it looks like it's limiting out to around 0.5, and on the right, coming down to 0 from the right, it looks like, those last two values, this one and this one, looks pretty convincing that the limit's going to be 0.5. Another way to see it, it's kind of fun. You use the trace button on the calculator, and you get this blinking dot, and you just move it on the curve, and you watch these values, the x and the y, and as you close down on 0 from the right, the last one that's visible before it clicks to 0 is 0.0425. So that's a pretty small number, and we're pretty close to 0.5. And then you go past that, trace with a blinking dot toward the 0, and see what the limit is there. So that's another way. Another way you can do it is second calc value. I did second calc value, and I plugged in 0.0001, which is 1 times 10 to the negative 4, and it gave me this y value. And you could also plug in, say you wanted to plug in some other one, like you could do second calc value, second calc value number 1, and put in also a negative value, which would be here, negative 0.00001, and then press enter, and you see that, see this, the y value is 0.50000125. So that's pretty convincing evidence that the limit really is 0.5. So we have, and it's equal coming from the left and from the right, so we're going to put 0.5 as the answer.